In this video I'm going to talk about heat and stoichiometry. And so, for example, let's do an example of nitrogen, which is N2. So here's two N atoms hooked together through covalent bonds. Oxygen, also two oxygen atoms bonded together through covalent bonds. And then they make and break bonds until you get an NO molecule and another NO molecule. So we say there's two of those molecules. There's one here, there's one here. So the reaction as it proceeds, well, these two have a certain amount of energy, and then the final product has a different amount of energy because some of the energy in bonds has been converted to heat, or vice versa. Maybe heat energy has gone into the molecule to make the bonds. So there's two cases. One is where the amount of energy in the products is higher than in the reactants. And this is the example we're going to do first. And so in the reaction, H has changed by 182, positive. Okay, and the units are going to be kilojoules. All right. Now, another way of actually writing this reaction is to write this as part of the reaction. And so if you want to think about it, 182 joules has to be put into the system to get it to here. And so you can think of it as a reactant. So you might see 182 kilojoules plus N2 plus O2 goes to 2NO. This and this are really saying the same sort of thing, just in different sorts of ways. So let's actually calculate the problem, okay? So how much heat energy is enthalpy is absorbed. So this is endothermic. So delta H being positive means the system has absorbed energy to go from reactants to products. So how much energy is absorbed when 10 grams of nitric oxide, or nitrogen monoxide to use the systematic name, is made? All right, so we have several conversion factors to consider. One is the molar mass of nitrogen monoxide, and that is going to be about 14 plus 16, about 30. So we're going to say it's 30.0 grams. All right, so 10 grams of NO multiplied by the molar mass, but with the grams on bottom, is that. Okay, now the other thing is that this number here is for 1 mole of N2, 1 mole of O2, and 2 moles of NO. So we need to know how much heat energy is for a particular thing. Now we have NO here, so we're going to say 182 positive is equal to 2 moles of NO. So that's the next step. So basically this first step says, hey, we have 1/3 of a mole of NO being made, if it's 10 grams being made, and then 2 moles of NO. 2 moles of NO is equal to positive 182 kilojoules. So basically 1/3 of 182 is the answer. $60.7. Now, heat energy is one of those things which is system size dependent. So if we were to make 20 grams of nitrogen monoxide by this exact same reaction, we need to use twice as much heat. Okay? And so this should make sense. Anytime you're in your kitchen and you need to heat up more water or do anything with heat, if you have twice as much stuff, you got to use twice as much heat. All right, so endothermic, add heat. Exothermic is just the opposite process, where delta H is negative and the products are lower than the reactants, and heat is given off by the system rather than going into the system. So those reactions are called exothermic when they're giving off heat. So those are the ones that feel hot to you because the system has energy. It's been converted to heat, and it goes into the surroundings because now it's hotter than the surroundings. Your hand gets burned.